Hello everyone, welcome back to another lecture of COP-3402. Today we're going to be going over the second half of the functions segment of the compiler project. We're going to be looking at how we can allocate space for parameters and how we can add support for nested function calls. So let's go back to where we had stopped last time. This was page 11, I believe. Let me type that correctly. 11, there we go. Okay. So what we want to do is save the caller's base pointer. So we had done this last time, but the way we had done it was really not very intelligent. So after executing a function call with the previous example we saw here, the base pointer would just store the value of the called function's stack pointer. This does not support nested function calls because when we go back up to the caller with this return instruction here, the caller's RBP value would now be set to the callee's, this called function example variable's, base pointer value. So we've essentially erased the caller's, or overridden it, the caller's base pointer value with the callee's base pointer value. So the caller now has no way to access its local variables anymore because we use the RBP register to access local variables like here, here, and here. So we need a more intelligent way to save the base pointer for callers. The way we do this is by using the stack. So right before we save or overwrite the RSP value in the RBP register, we just push RBP's old value onto the stack. And then when we're done executing the function, we pop the old RBP value to restore the caller's base pointer so that they can continue accessing their local variables. Here's an example of the setup for a stack frame that follows this schema. I'm going to put it on the left now and show a walkthrough of this with an arbitrary stack on the right. So if we assume, I can actually verify that my Scala draw works, there we go. If we assume that this stack frame begins at address 64, this function example variables must have been called by some other function, so the return address for this call to example variables that we're inside of has to be at 64 as well. So we're going to assume the RSP is at 64. The return address is also at 64. The first thing we're going to do is push the value of RBP. So we're going to assume that RBP has an old value of 128. So we're going to, the first thing we do with a push is increment the stack pointer, or decrement it, I should say, because the stack grows downward, so we decrement it by 8. Then we're going to put the value of RBP into the memory location that RSP stores, so 56. Now we're going to move the RSP into RBP to overwrite the RBP register with the current RSP of this stack frame. Then we're going to subtract 16 from the RSP to allocate space for our local variables. So remember we had said previously that this function example variables has two parameters, x and y. So we need to allocate 8 bytes per parameter. So 8 times 2, 16. So now RSP points to 40, and we have effectively allocated space for two variables that I'll give the names of right now, x and y. And you might be wondering, well, why does RSP store 40 if y is at address 40? And the reason why is because if RSP were to be changed at this point, it would be from another call instruction. And a call instruction would first push the return address onto the stack. So if we were to have another call instruction, it would actually decrement RSP first to 32, and then put the return address of that new call right here. So we would not be overwriting y. So we actually want RSP to store the address of the last local variable. Now that we've subtracted the space necessary for our locals, we can execute our body of our code here, add 16 to RSP, so 56 to deallocate the space for our local variables, and then pop the value of RBP. So we're going to take the value that RSP points to, 56, take the value there, put it into RBP, and then increment RSP by 8 because we executed a pop instruction, and the next thing we have to do after getting the value is increment RSP to pop off the stack. And then we can execute the return instruction here. So we're going to look at what RSP points to. At address 64 is the return address from this function. We're then going to branch to that return address. So the big idea of what we've done here is set up a function prolog. So in the prolog, we're going to be pushing RBP to save the caller's base pointer, moving RSP into RBP to set up the new base pointer for the function we're now executing. And then we're going to subtract enough space to subtract enough memory values here, subtract a large enough value from RSP to allocate stack space for our locals. So it's going to be 8 times the number of local variables we have. Then in the epilogue, we deallocate space for those locals, we pop RBP to restore its old value, and then we return to go back to the calling function's instructions. Now to demonstrate this, we have another example here of a caller and a callee. So the caller is going to be this main function with one local variable, retval. Retval is going to be assigned to the result of a call to example variables. And example variables, we have local variables x and y, x equals 1, y equals x, return y. Let's step through the assembly code for that call to example variables. So again, we'll just assume that the return address is on the stack because it has to have been if example variables was called by main. This call instruction will, of course, now the translated assembly code call instruction would, of course, push the return address onto the stack first. So we'll just assume that RSP is at address 64 and stores the return address going back to main. So the first thing we're going to do is push RBP onto the stack. So we're going to decrement RSP by 8, put the value 128 onto the stack. Then we're going to move the RSP into RBP. So we're going to move 56 into RBP to set up the new base pointer. Then we're going to allocate stack space for the locals by subtracting 16 from RSP. So 56 minus 16 is 40. Now we're going to execute the actual body of this function. So we're going to move 1 into RAX. So RAX should be 1. And then we'll move the value in RAX into -8 offset from RBP. So RBP is at 56. 56 minus 8 is 48. So we're going to move this value 1 into address 48. And just to clarify, I'll draw here what variables are occupying what part of the stack. So X is going to be occupying this segment of the stack, and Y will be occupying this segment. And to check our work, we can see that RSP correctly points to the address of the last local variable, Y, as it should. Now to execute the rest of these instructions, we're going to move the value of X into RAX. So X is at offset -8. At this offset, we have the value 1. RAX already stores 1, so we have to do nothing. I won't change the diagram. And then for the next instruction here, we're moving the value in RAX into -16 RBP. So RAX stores 1. RBP is 56. 56 minus 16 is 40. We're going to move 1 into that offset memory. Next, we're going to return Y. So we're going to move Y's value, -16 RBP, into RAX. So 1 goes into RAX. RAX already stores 1, so we'll just leave it as it is. And again, we're moving this value into RAX because by convention, return values of functions are stored in the RAX register. Now for the epilogue, we first add 16 to RSP to deallocate space for the locals. So we're going to add 16 to RSP, 56. Then we're going to pop RBP to restore RBP's old value. So at address 56, we have 128. We're going to move 128 to RBP. Then we're going to decrement or increment RSP by 8, so to get to 64. Then finally, we're going to return. So we're going to look at the address that RSP stores, 64, get the value there, which is the return address, and we're going to jump back to this address to resume execution of the main function here. Okay, so now let's talk about calling conventions and how we can actually handle parameters and local variables and who is responsible for what. So in general, for a instruction set, its application binary interface, or ABI, tells you whether the caller or callee is responsible for allocating space for local variables, assigning parameters, storing the return value, the return address. The ABI tells you all of this. And for us, we're going to be following the system V, system 5, perhaps, I'm not sure if it's V or 5, system V x86-64 ABI. So according to this ABI, the caller manages the stack allocated parameters and the return address. The callee manages the old base pointer and local variables. So we've already seen this, how we can manage the base pointer with these push instructions for RBP and allocating space for local variables by subtracting and adding to RSP. The return address, that's of course managed by the call instruction. And stack allocated parameters, we will see that shortly. So for passing parameters, we pass the first 6 parameters according to the system V ABI. We pass the first 6 parameters via registers for our function call, and the remaining parameters after the first 6 are going to be pushed onto the stack in reverse order. And we don't have a good example in these slides about pushing on that many parameters onto the stack. But I think on the website we do have examples, and if not, I'll add them later. And of course, you should definitely write your own tests to test the execution of functions with more than 6 parameters. And this just shows you kind of who's responsible for what. So the caller is responsible for everything up here, and the callee is responsible for all these other parts of the stack frame. And to show a complete example of parameter passing now, we're going to look at the simple IR code and then the corresponding assembly code. So if we have some function main with 2 local variables, retval and x, we're going to say x equals 3. Retval is equal to the call to the function func, passing 1 argument x, and then we return retval. In the function func, we have 1 local variable, a, which is a parameter, and then we just return that parameter, that argument. And then we end the function. So now here's the corresponding assembly code for that simple IR code. Now I'm going to jump over to Vim here. So I recognize that this is hard to read, so I prepared this same code in Vim and should be easier to read that way. And now on the right, I'm going to scroll down to an arbitrary stack frame I've set up for this example for us to step through. So we're going to start with the main instruction, which presumably was called by _start. So we're going to assume that the RSP, the stack pointer, is at address 88 after the call instruction from _start. And so the return address back to _start from main, we're going to store it at address 88. That will be at the bottom of our stack frame here. The first thing we do inside of main is push the RBP register. So we're using push Q because we're dealing with 64-bit values, which is a quad word, 4 words. There's 16 bits in a word. 64 is divided by 16 equals 4. And so we have a quad word. So we're only dealing with quad word 64-bit values, so we use push Q instead of push. So we're pushing RBP onto the stack. So we're going to decrement RSP by 8, so we have 80. And if we assume RBP has some original value of, again, 128, we'll just store that here. We'll, of course, put 128 into the address 80. Then we will set up the new base pointer for our call to main by moving RSP into RBP. So RBP is going to become 80. Then we will push RBX onto the stack as well. So we'll assume RBX has some value. We'll just say 7. So we, of course, we decrement RSP by 8 again because we executed a push instruction. And now we allocate space for the locals for main. So main has 2 local variables, ret val and x. So we're going to subtract 16 from RSP. So 72 minus 16 is 56. Now we're going to assign 3 to x by moving the value 3 into RAX, and then moving the value in RAX into the offset where the x variable is. So if I go back up, or I believe I can just actually write this in here. X should be at this location, not C, not C, X, there we go. X should be here, and I believe ret val should be here. So at offset -24 from the RBP, that's going to be 80 minus 24, 56. So at 56, we will store the value 3 because RAX stores 3. Now we're going to make a call to the function func. So we're going to pass the parameter of x to pass the argument x as the a parameter of func. So we first use, because the first 6 parameters are passed via registers, the first register that we use for passing these first 6 is going to be RDI. So let me actually write this in as another box here on the right. And we're going to move the value in negative offset 24 from RBP. So that's going to be 56, the value of x. We're going to put that in to the RDI register. And now we're going to execute the call instruction. So we're going to call func. So the first thing we do with call is push a new value onto the stack. So we're going to decrement 56 by 8, so we get to 48. And then we're going to store the return address from main onto the stack. The return address in main from func onto the stack. So let me write this in here. I'm going to copy this, paste it in. So we're at address 48. Yep. We're going to say from func now. And by from, I mean this is the callee, the function we're returning out of, going back to the caller from. So now we're going to branch to the first instruction in main, or in func, I should say. So the first thing we do in func is push the new RBP onto the stack. So we're going to decrement RSP by 8, so we get to 40. And then we put the value 80 onto the stack. Next, we set up the new base pointer. So we're going to move the value 40 into RBP. Then we push RBX onto the stack. So again, we just have to do this to follow the ABI. So we decrement the base pointer to perform the push. So first we decrement this to 32, if I can type this, 32. Sorry, it's a little dark here and it's hard for me to type the numbers. So RBX, and then we're going to put RBX's value at address 32. It's going to be 7. Then we're going to allocate stack space for our local variables by subtracting 8 times the number of local variables. So func only had one parameter, one local variable, I should say. So we're going to subtract RSP by just 8, so we're going to have 24. And effectively what this does is give us the address of, let's see, we had said A was here. Yeah, that's correct. Okay. And then we're going to, so to get the parameter that was passed to func out of the parameter that was set up in main, so remember in main we had passed the value of x into RDI, we have to actually move the value out of RDI into the parameter A. So if A is stored at offset -16 from RBP, 24, then we have to move the value out of RDI into the variable, the place where the variable A, local variable A, is going to be stored for func. And we would do this for all the locals stored in all the parameters passed. You would do this for all the parameters. So after doing this, we then, remember, all we do in func is return A, so we move the value at -16 RBP. So it's RBP is 40, minus 16 is 24, get the value 3. We're going to copy this into RAX, so we just have 3 in RAX. It's already there, so I'm not going to change anything. And then we execute the epilogue. So we add 8 to RSP to deallocate space for the locals. Then we pop RBX to restore the old base pointer. So at 32, we have, actually this is incorrect. This comment here is wrong. We pop RBX to follow the ABI. So we're popping RBX. So this is going to be at address 32 is 7. So we're going to put 7 into RBX. 7 is already there, so I'm not going to change this diagram. Then we would, of course, decrement RSP by, or increment it by 8 because we popped a value. Then we execute this pop instruction here, popping RBP. So we're going to take the value at address 40. That's 80. We're going to put 80 into RBP. Then we're going to increment RSP by 8 more because we just executed a pop instruction. Now we're going to execute a return instruction. So we're going to now look at the address that RSP stores, 48. We're going to branch back to the instruction that follows the call instruction that brought us into the func function. So we'll go back to up here, call to func, and now we'll be at instruction right here, this instruction. Which would be, yeah, this move instruction. And I believe this actually pops the return address from the stack, so we would actually be back at 40 now. I'm sorry, 56, because the stack grows downwards, so to pop we would go back up one more, so we'd be back at 56. So now we continue execution from here. Move the value in RAX, we're getting the return result, we're getting the return value out of that call to func. So we're moving the value in RAX, 3 into -16 RBP. So RBP is now 80. 80 minus 16 is 64. So we're going to move 3 into the offset, into the memory address 64, which is where the retval variable is. We're then going to set the return value by moving the value at -16 RBP into RAX. So we're saying we're returning the value in retval. So we're going to move the value here 3 into RAX. RAX already stores 3, so no need to change anything. Then in the epilogue, oops, let me close this. Now in the epilogue, we will add 16 to RSP. So 16 plus 56 is going to be 72. Then we will pop RBX to restore the old RBX value. Again, this comment here is wrong. We're restoring the old RBX value. So at 72 is 7, so we're putting 7 into RBX. Nothing changed, so we're not going to change the diagram. But because we executed a pop instruction, we're going to increment RSP by 8. Then we're going to pop RBP to restore the old base pointer. So we're going to go with the address that RSP stores, 80. Take the value there, 128, put it into RBP. And then, of course, increment RSP by 8 because we executed a pop instruction. And finally, the last thing we do is return. So we're going to go to address 88, get this return address from the memory address here, and we're going to go to that instruction address in our code here on the left. And it's not shown here, but presumably it would be some address inside the underscore start function. So underneath the underscore start symbol in our assembly code. So I hope this was an illustrative example for how you'd pass parameters in assembly. Again, we don't have an example of more than 6 parameters, but I encourage you to go to the course notes and you can find some good illustrations and diagrams and drawings of how you do that. And you'll have to implement it yourself with the compiler. It's not very hard. I would just say, remember that you have to pass all the parameters after the 6th parameter via the stack in reverse order. That's key. So good luck. I'll see you next time in class.